Welcome to YQ Academy, SQL Interview Questions and Answers. 1. What are different types of collation sensitivity? 1. Case-sensitive. In a case-sensitive collation, uppercase and lowercase letters are treated as distinct characters. For example, A is different from A. Case-sensitive collations consider the binary representation of characters for comparison and sorting purposes. 2. Case-insensitive. In a case-insensitive collation, uppercase and lowercase letters are considered equivalent. For example, A is considered the same as A. Case-insensitive collations ignore the distinction between uppercase and lowercase letters in string comparisons and sorting. 3. Accent-sensitive. In an accent-sensitive collation, accented characters are considered distinct from their unaccented counterparts. For example, E is different from E. Accent-sensitive collations take into account the accents or diacritical marks on characters during comparisons and sorting. 2. What is OLTP? Online transaction processing? OLTP, or online transaction processing, refers to a type of data processing that focuses on managing and executing a large number of concurrent transactions in real time. It is commonly associated with operational databases that support day-to-day business operations and transactional activities. The primary goal of OLTP systems is to facilitate efficient and reliable transaction processing, which involves the creation, modification, retrieval, and deletion of data. Key characteristics of OLTP systems. 1. High concurrency. OLTP systems are designed to handle a large number of concurrent transactions from multiple users simultaneously. This requires efficient locking and concurrency control mechanisms to ensure data integrity. 2. Low latency. OLTP systems prioritize quick response times to support real-time transaction processing. Users expect near-instantaneous response when interacting with the system. 3. Small, frequent transactions. OLTP systems are optimized for handling small, atomic transactions that involve individual records or small sets of data. These transactions often involve simple read and write operations on specific data elements. 4. ACID compliance. OLTP systems adhere to the ACID atomicity, consistency, isolation, durability properties to ensure the reliability and integrity of transactions. ACID properties guarantee that transactions are executed reliably and consistently, even in the presence of failures. 3. What is the use of update_statistics command? The update statistics command in SQL Server is used to update the query optimization statistics for one or more tables or indexes in a database. Query optimization statistics provide valuable information to the SQL Server Query Optimizer, which it uses to generate efficient execution plans for queries. The update statistics command helps ensure that the Query Optimizer has accurate and up-to-date statistics, which is essential for producing optimal query plans. When the underlying data in a table or index changes significantly, the existing statistics may become outdated and can lead to suboptimal query performance. By updating the statistics, you provide the Query Optimizer with the most current information about the data distribution, density, and selectivity, enabling it to make better decisions when generating execution plans. 4. What are the properties and different types of subqueries? A subquery, also known as a nested query or inner query, is a query embedded within another query. It is used to retrieve data based on the results of another query, allowing you to perform complex and advanced data retrieval operations in SQL. Subqueries can be used in various parts of a query, such as the select, from, where, and having clauses. Properties of subqueries. 1. Nesting. Subqueries can be nested within other subqueries, allowing for multiple levels of subquery depth. This nesting capability enables you to create complex queries that analyze data from different angles. 2. Independence. Subqueries are independent of the outer query and can be executed separately. The result of a subquery is treated as a temporary table, which is then used by the outer query to perform further operations. 3. Data filtering. Subqueries are often used for data filtering purposes. The result of a subquery can be used to filter the rows returned by the outer query based on specific conditions. 4. Comparison. Subqueries can be used for comparisons by returning a single value or a single row result set. These values can then be used in comparison operators such as equal, greater than, less than, etc. within the outer query. Types of subqueries. 1. Scalar subquery. A scalar subquery returns a single value and is usually used within a select statement or as part of an expression. It is typically enclosed in parentheses and can appear in the select list, where clause, or having clause. 2. Single row subquery. A single row subquery returns a single row result set and is used to retrieve a single row of data from a table. It can be used in the from clause or the where clause of a query. 3. Multiple row subquery. A multiple row subquery returns multiple rows of data and can be used to retrieve a set of rows from a table. It is commonly used with operators like in, any, or all to compare a column value with a set of values returned by the subquery. 4. Correlated subquery. A correlated subquery is a subquery that refers to a column from the outer query. It is executed once for each row of the outer query, making it dependent on the outer query's context. Correlated subqueries are typically used when you need to perform calculations or comparisons based on values in the outer query. 5. What is SQL Profiler? SQL Profiler is a tool provided by Microsoft SQL Server for capturing and analyzing events and activities that occur within an instance of SQL Server. It allows you to monitor and capture SQL Server events in real time or by using trace files. SQL Profiler provides valuable insights into the performance, behavior, and efficiency of SQL Server queries and transactions. Main features and uses of SQL Profiler. 1. Tracing SQL Server events. SQL Profiler allows you to trace and capture various events that occur within SQL Server, such as SQL stored procedure executions, database changes, login/logout events, errors, and more. You can select specific events to trace based on your monitoring requirements. 2. Performance monitoring. SQL Profiler helps identify performance bottlenecks by capturing and analyzing the execution times, resource usage, and query plans of SQL statements. This information can be used to optimize queries, indexes, and database design to improve overall performance. 3. Troubleshooting. By capturing events and errors, SQL Profiler assists in troubleshooting database-related issues. It helps in diagnosing problems, identifying slow-performing queries, detecting locking and blocking scenarios, and finding errors or exceptions raised during query execution. 4. Query analysis. SQL Profiler provides a detailed view of query execution, including the sequence of events, the order of SQL statements, and the duration of each step. This helps in understanding query behavior, identifying inefficient queries, and optimizing them for better performance. 5. Auditing and compliance. The SQL Profiler allows you to capture and log database activities for auditing and compliance purposes. You can track changes made to the database, monitor user activity, and generate reports to ensure adherence to security and regulatory requirements. This is the end of our SQL interview questions. We hope you enjoyed learning with YQ Academy. Until next time, goodbye.